start with.
Okay, hello everyone. My name is Martin, and my topic today is SHACL-based Object-ontological Mapping. So I will probably start with what actually means Object-ontological Mapping. So it's obviously it's a mapping between an ontology and an object model. In our case, an object model of an application. The mapping at first sight is actually quite simple. So we map all our RDFS classes to reference types, which in Java is classes and interfaces. Object properties, if we take all terminology, object properties are mapped to reference type members. So attribute or fields of reference type types. Data type properties are mapped to basic type members, which are basically primitive types and their wrappers, strings, and date time types. And annotation properties can be basically both reference types and basic types. And the last ontological term that we can use here is class assertion. And that is mapped to basically an instance of relationship between an object and its corresponding class in the programming language or in the object model. So these are the basics of the mapping. The problem is that semantic web ontologies by default use what is called an open world assumption, which is basically that when you don't have some fact stated, it doesn't necessarily mean that it's false. It just means that it's unknown in the current ontology or in the data that are available, which often leads to the reasoner just inferring some new instance or new assertion for the data so that the database or the knowledge base stays consistent. I have an example here. So we have an axiom which states that every friend of a person is also a person. Then we have X, an instance of person, and we say that X has a friend Y. But since we don't state that Y or we don't say any classification for Y, the reasoner, to stay compliant with the first axiom, will infer that Y is a person as well, which is not usually what we want for information systems, because the information systems usually, or domain-based information system, domain-specific information systems, usually work under the closed-word assumption, so that if they don't have the data, they assume that it's false. So in this case, we would like the system or the database to notify us via some error that we are missing classification for object Y. Yeah, so the database in our case should be inconsistent. This is handled differently in different semantic web languages. So for all, there is no standard for this, for the integrity constraints. There are several proposals, but none of them is standardized. What the JOPA uses is what's called all axioms with integrity constraint semantics, which is basically that you can treat regular all axioms as integrity constraints and give them close towards semantics. So in this case, in the example, if we would take the first axiom and we would say, okay, this is an integrity constraint, then it would work as we expected. So this assertion here would, or the database with this assertion and this assertion would produce an error because Y is not an instance of person. Yeah, so that's for all. For RDF or RDF in general, there actually is a standard. It's called SHACL, and that's basically an answer to the problems of the community, who recognize that integrity constraints are needed in many scenarios when using semantic data. Integrity constraints that we use are basically for or in the context of the object ontological mapping, we can separate them into three categories or kinds. If we take into account compiled programming languages like Java. Yeah. So the first kind is what we call compile time integrity constraints, which are validated by the compiler. So before you even run the application, you know what the constraint produces. The second one, or the second category, are runtime constraints, and those are validated by some routines within the library that provides the object ontological mapping. And the last category are reasoning time, which are basically validated by the reasoner or the repository that stores the data. I will show you examples when we deal with the actual with the example of the object ontological mapping. Okay, so our topic, or what we are concentrating here on, is SHACL, which stands for Shapes and Constraints Language. So it's a W3C standard for integrity constraints in RDFS, or validation of RDF graphs. Basically, what it means is that you define what's called shapes, and these shapes represent prescription of how the data should look like. So the data are validated against these shapes, and if the data doesn't comply with the shape, then you get a validation error. It's quite well supported in the triple stores and some of the tools. So in the Java world, which is what we deal with mostly, Jena and RDF4J supports SHACL, no problem. GraphDB and Stardock as well. I didn't really find any statement of support for Virtuoso. There are some issues open on their GitHub, but apparently it's not implemented in Virtuoso at the moment. There's also a tool called PySHACL, which is part of the RDF-lib, which is basically an ecosystem of tools for working with RDF in Python. So PySHACL allows to validate RDF data against SHACL graphs. The standard actually consists of two parts. It has what's called a SHACL core and a SHACL Sparkle. SHACL Sparkle is basically allows validating data by arbitrary Sparkle queries. And that's out of scope of the object ontological mapping that we want to do, because since the queries can be basically arbitrary, it wouldn't make sense to try to make an object ontological mapping based on them. Okay, here is some basic example of a SHACL shape. I took it from the specification itself. So we see that we have a shape defined. It has a target class. So this defines the nodes that will be validated by the shape. So all instances of class person will be validated by this shape. And specifically, what we are looking at are properties of these instances, and we are interested in the property which is called SSN. And we say that we expect at maximum one value of this property. The value should be of type string, and it should have this, or it should match this like regular expression. Yeah. Another restriction that we have for the instances of person is that for a property called works for, we expect its values to be of type company, and we expect that the values will be identifiable. They won't be. They will use IRI, and they won't use blank notes, for example. Yeah. And besides the classification of the instances, this is all the properties that we expect each person to have. If there are any other properties, the data will be invalid again. Yeah. So this is a basic example of how SHACL shapes look like. What we will be using for the object ontological mapping is quite similar. So we will always use a node shape with the target class, because you can the focus node, or basically the validated data, could be anything else. It could be different. It doesn't have to be a class specifically. It could be, for example, all property assertions of some specific property. But in our case, we are interested in classes. So our shapes for the mapping will always have a target class. And they will always have properties which will define the attributes of the object that we expect to map. Yeah, and for the properties, there will also again be some rules. So we will always have what the specification calls a predicate property path, which means that the property or the path is of length 1. So no alternative properties, no property paths of length n, no inverse properties, nothing like that. Just a simple single property that we are interested in. And then we will have the constraints for that property. Yep. So here are the constraints from the SHACL specification, and I have split them into categories based on how we can use them in the object ontological mapping. So the first ones are the compile time constraints. So we can use the class and data type constraints, which basically tell us what will be the range of the property. So if we want the property to have the values to be of specific class, or in case of data type properties of specific data type, we can use this constraint. And this constraint will translate to basically type in the target Java or object class. Yeah, so the type of the field for a Java class, for example. Yep. And another constraint that we can use under the condition that under some specific condition, in this case, the max count constraint. If the max count value is 1, we can use it again as a compile time constraint, and that basically just tells us that the attribute will be a singular, so that we expect at most one value of this specific property. So these are the constraints that we can use that we can compile directly into the target model. Again, I will show an example in a minute. And then there is a bunch of constraints that we can validate at runtime. So the min count and max count, that's in JOPA, it's already supported. That's the participation constraints annotation. So basically, we validate that the property or the attribute has at least that number of values, or at most that number of values. So for example, we can say that an object has to have at least one first name or whatever. Yeah. The other constraints are not currently supported in JOPA because they don't really have a corresponding all axiom representation. But it would be quite easy to implement them or extend JOPA with them. So min exclusive, min inclusive, and so on for numeric values for properties. So if we have a property with a numeric value, we can validate this specific value or all the values of the property. For string-based properties, we can validate the length of the value, or as we saw in the basic example of the SSN, we can validate it against some regular expression. or we can even validate the language of the value. And lastly, we might have some very specific constraints like has value, which just says that at least one value of some property has to be equal to the value specified in the constraint. Closed, we already saw that just means that we expect the object to have just a defined set of properties, nothing else. And we might ignore some properties for this with respect to this closed constraint. So we might say, okay, it's closed, but these properties we don't care about. They can be there or they may not be there. We don't really care about. Okay, and the last are constraints which cannot be easily validated by the persistence library or the object ontological mapping, but we can use either the reasoner or the repository, which basically will be some reasoner in the repository to validate directly on the data, and that's equals. So we expect the value of the property to equal to something always, or that the values are disjoint with some set, or that the values are less than something. So for example, in the specification they have an example that you have a date and you expect this date to be less than something. So for example, date of creation should be less than today. Yep. And then some logical operators like not or XOR. There's also SH-AND, which is basically a conjunction of constraints, but that's basically implied by if you put multiple constraints on the same property. So for example, we can have a property and we can restrict its values with min exclusive and max exclusive, and we can use AND, SH-AND for conjunction of these two constraints. But we usually don't do that. We usually just write it in the same shape like it's here. Yeah, so we could split this part with the constraints on the SSN property into multiple declarations, and then they could be connected with the SH-AND. But we usually don't need that. There are also some special cases where the constraints are more complex, but that's not really interesting for us for the object ontological mapping. Okay, so that's in theory how it should look like. Now I have some example, a very simple example, obviously for the purpose of the presentation. So I have an object model or a conceptual model, basically, where I expect that we have a class of report and another class called person. And we expect that the report will have exactly one creator and at most one last editor. And both of them would be of type person, and the person class has the first name and the last name. So here are the corresponding shapes. So for the report, we say that we are interested in instances of class report, and we constrain the property the creator. Its values should be of type person, and we expect exactly one value. And then for property last editor, again, we expect the value to be of type person, and we expect at most one value. And for the person, we are interested in instances of person class, and we expect each instance to have exactly one first name of type string and exactly one last name or surname, again of type string. And this model is quite easily translated to a corresponding Java model. Here we use the JOPA. So we have a class report identifier that's implicit for each instance or each class in the object model, and then we have an attribute creator and another singular attribute that was the max count constraint, another attribute last editor. And for the creator, we also use the participation constraint. This is basically shorthand for min count equals 1. So we expect that there will be a value of creator. Okay, and the class person is very similar. So we have two attributes, first name and surname. Both are of type string, and both are required, are singular, and the values are required. So that's in basics what the mapping would look like. It's actually quite simple on the surface, but there's a but. That's basically what JOPA, for example, had originally was this convention-based mapping. So we said, okay, these are the types of axioms that we support, and this is how they are translated to Java. But there is no formalism again behind this, or there wasn't any formalism behind this. So it was basically, yeah, it's supposed to look like this, but there's no proof that it's faithful to the data, to the ontology. We did that recently using flogic as a middle step, and now we would probably like to do the same for the SHACL-based mapping. So we would like to formalize this mapping probably by translating SHACL to description logic. There are some papers that I already saw that do that. And then we could use the framework that we already did for description logic and flogic that we already have. So we would use that to translate the mapping from SHACL to the object programming language. So that's the theoretical step. The practical step, which is probably much more interesting, is basically adding support for SHACL-based mapping to JOPA, which would consist most likely of implementing a new module which would be able to generate an object model from a set of SHACL shapes. Similarly to how now all2Java is able to generate object model from a set of all axioms, all constraints. Add probably new runtime validators for some of the SHACL constraints that are currently not supported. That's the min exclusive and min length and so on. But also adding some API which would, or maybe it's, now I'm thinking about it, we probably don't need an extra API. If the repository constraint contains the graph, the SHACL graph, basically what we would do is at the end of each transaction, we would call validate on the repository. Or we might have an API which would allow the users to pass a SHACL graph, and we would and JOPA or JOPA would use that on every transaction commit to validate the data in the repository. Probably both options are possible. So that's how the mapping or could look like, and what the next steps in the mapping would probably be. And that's it. Here are some resources that I reference in the slides. If you have any questions, feel free to ask.
Sorry, I have a stupid question because I had to go away for a moment, and you said it during that time. Is it possible to use these shapes to create the mapping?
Not at the moment, but the goal is to be able to do that.
Okay, yeah. Nice. Yeah, that's it. Thanks.
Okay, then I have a question. Thanks for the presentation. It was very nice. I'm a little bit lost related to reasoning time versus runtime validation. If you could go to the slide where you showed examples, what SHACL this one. So you said that less than is something to validate date, whether it is lower than something or I don't know. Why is this reasoning time and not runtime or other? Oh, and why, how it is different from min inclusive? Is min inclusive integer validation? I'm not sure why you split it like that.
Yeah, I think the less than or the less than or equals constraints are used to reference some other property values. Actually, yeah, that was the the date example. Was that you have a date and you expected it to be less than value of another property. So, for example, if you would have an occurrence and it would have or an event and it would have a start time and an end time, the constraint would be that the start time is less than the end time. So you need the values of two properties to validate this constraint. Yeah. So I even misinterpreted the example from SHACL, from the specification.
Okay, so what separates runtime from reason time? Is it just whether it is directly attached to object, or what? When do you say it's reasoning time and runtime constraint?
Yeah, basically, if you look at the constraints, the runtime constraints can be the value of the property can be directly validated without access to any other data. Yeah. So, for example, max inclusive, we get the value of the property and we know what the maximum is, and we don't need any other data. When compared to, for example, the less than, we would need the value of the other property, which is something that is not loaded by JOPA by default, unless it's another attribute. Yeah. So that's the basic difference between these. The same for example, the disjoint or equals. Yeah, it's usually meant that you need to compare it to some other values in the repository, and it not just validating the value directly against some predefined value like the min length and exclusive or inclusive maximum or minimum.
Okay, so when I have property, I have simple property path of, for example, DC creator, and at the end of the path there is a class. Then this is even compile time, right? Or not?
Yeah.
And okay, and if I have if I have path of length 2, this is not compile time anymore, or is it? Or
That's not supported by the mapping at all. We are only interested in properties or path of length 1. I mean, it could be, in principle, it could be added to the mapping as well, but that would complicate the mapping a lot, because you would have n intermediate objects across which you map the attribute. So you would have an attribute, but the value of the attribute would not be directly reachable by single property, but you would have to traverse multiple properties across multiple objects. And if you set a new value for the property, and it didn't exist before, then it might happen that you would have to create these intermediate objects. So that's why we are interested only in properties or property paths of length 1.
okay. I mean, in case you have entity and you have you fetch related entity eagerly, then you could use it to do the runtime constraints. That's what I thought. Well, I don't know if this is correct thinking. It's just I have a little bit. I'm not 100% sure if I would be able to identify when you tell me for the SHACL primitive whether it belongs to runtime or reasoning time. But I guess it's for a longer discussion, or I don't know. Okay. But thanks. It's more clear to me. And what I was not sure why you said that SHACL Sparkle is out of scope. It should be at least reasoning time or something like that, right?
Yeah. I think the main problem with this is that you always want to have the compile time constraint, at least one of them. Yeah. You always want to have class or data type constraint. Otherwise, for example, the type of the attribute would have to be object, because you don't know what will be the value. Yeah, you don't specify it, so it could be anything. Yeah. Once you have that, you can in principle have Sparkle-based constraints and treat them as reasoning time. Yes, that's true. That's true. Yeah.
Okay. Thanks. I guess that's all. Thank you.
Okay. Thanks. I guess that's all then. Yeah. Can stop.